Starting the stream here.
Like,
5, 4,
use Excel.
3. Wait, hold it. We're gonna go into it. 3, 2, 1. Okay. So welcome back, everybody. We here at the table, all of us here at the table. We took a vote and we decided that we actually want to talk more about databases than about classless JavaScript. So that's what we're gonna do right now. So if you are in on YouTube or Twitch or wherever it is that you are, and you find that this is a useful discussion and you like it, well then, give it a like, subscribe to the channel, whatever. And we may end up still talking about classless JavaScript, but if we do that, then I'm gonna stop and restart the stream when we get to that point. And I'll try to have the chat up. And so with that, yeah, let's talk about databases. So we were talking about Postgres, we were talking about Mongo, we were talking about
LMDB, Lightning Map Database.
Okay, so, all right, I don't even know how to moderate this, but y'all had some discussion over here, so let's just go over here first. And let's talk over there first, and then we'll just go around the table.
Spotlight.
So yeah, you get the spotlight, it's no big deal.
So, no, I was asking you, so you're using Azure, right?
Yeah, I started learning Azure last week, and that's all I've been doing for the past week. So I'm pretty limited in terms of SQL experience, but I mean, I've liked it so far. I've liked the IntelliSense it provides, and I'm using it in tandem with SQL Server, and I'm using Docker on my MacBook Pro to be able to do that since it is Windows based. So that's about everything.
SQL Server works on Linux perfectly. FYI.
Okay, good to know.
There's also an MS SQL like Docker thing that I
Yeah.
used for a bit, or
And that's what I'm using.
yeah.
Yep.
So,
So, I'm just curious to hear your guys' thoughts on what database, relational database management systems you use. Yeah.
Well, hold on. Let's dig a little bit deeper too, because it's not just the database; it's also the layer into the application, right? Because your application has to use this.
Mm-hmm.
So,
Right.
what are you using to go in between?
So right now, my focus has just been on the RDBMS. I haven't actually used it with the front end at all. It's been purely back end.
Well, have you done any of the JavaScript modules to connect to it, or
Not yet.
so you're just writing pure SQL?
Pure SQL.
Okay.
So I haven't connected it yet I haven't bridged the gap between back end and front end. It's just pure SQL running queries. I created the library management system, which would keep track of books being checked out from a hypothetical library and who has the books, what branch has the books, and things like that. So it was actually pretty complicated to do that. So, yeah.
So one thing to note, if you're using SQL database, so who here uses SQL databases? So we got everybody except Jeff.
I'm sure we've got some somewhere, but yeah.
You just throw the tried and true technology out of it.
7 years ago, I was using Postgres. Different job.
Okay. Anyway, so the thing that sucks about SQL, and I think this is why we have opportunities in the market for things like MongoDB, is that there's no standard for SQL. There is a quote-unquote SQL standard, but it doesn't define anything useful. It defines how to do a select and a join, and that's the extent of it. So all the stuff that you're learning for SQL Server, how you quote things, I think in SQL Server you put brackets around things to quote them, if I remember correctly, square braces or quotes.
Yeah. Yeah.
Mhm. Yeah. So in MySQL, it's backticks. In Postgres, it's single quotes for identifiers and double quotes for values.
yeah, it's something like that. Because I tried switching single double and complaining about it very hard.
Yeah, I think single or double will work for values, but only single will work for identifiers or something like
So
that.
is SQL being less and less popular every year?
No, it's not that it's less popular. It's that you pick a database and you become expert in that database. But there's no such thing as SQL. It's very
Right.
loose. From a mathematical
There's
perspective.
MySQL, NoSQL, all these different.
NoSQL is just categorical.
Oh.
So everything that isn't SQL is NoSQL, just categorical.
Oh, okay.
Like
Okay.
Mongo doesn't have a SQL interface.
So
You can't use SQL to query Mongo, regardless of
Interesting.
the flavor, whereas
Okay.
what AJ is saying is that every database is a slightly different flavor of SQL. Most
Right.
of them look pretty similar, but.
Okay.
Wait, so what is the difference between all of them?
Because
it's unimportant garbage.
Okay, unimportant.
So like most people will choose like Mongo if like they want to store a user and his profile.
Oh.
And just all his data is gonna be in one chunk.
Hmm.
You can access it with just getting that row.
But there's no
Which-
structure to it, right?
Right.
Oh,
Sorry, you meant between SQL and NoSQL, not between the different SQL databases.
I did mean between the different SQL databases.
Oh, okay, because
So like MySQL versus Postgres, for example.
It's different.
Because I've tried both
Isn't
and
it
they seem
minute?
really similar.
They each have a few features that the other doesn't have,
Okay.
and there's some subtle performance differences if you really want to get in the weeds, though I think MySQL used to be terrible with, was it MyISAM? Is that the one
Yeah.
that was horrifically bad, performance-wise? But they've got the, I can't remember the newer, NodeDB, which my understanding is performs just fine.
Is that like the engine?
It's like the storage engine,
Yeah.
really.
So like foreign keys used to be pretty terrible for performance, but
Okay.
I mean, since MySQL exploded in popularity because everything's been PHP, and that's like, you know, the number one backend that people use, so.
I mean, honestly, a lot of the decision-making in choosing a DB can come down to the license for developers and like what sort of, like license the database is released under and how you can use it and, yeah. I mean,
If you hate money, Oracle.
yeah.
I don't know if there's any that are egregious like Oracle.
oh, and by the way, MySQL is not the name of MySQL anymore. It's now called MariaDB. Because Oracle bought Sun Microsystems, which had which would bought MySQL, and so because of the trademark, and Oracle has no use for another database because Oracle already sells an enterprise 10 grand per seat database. So MySQL doesn't mean anything to them, but they are a patent troll. Oracle does two things. They sell legacy software and they patent troll. And so once they acquired the trademark for MySQL, the author of MySQL had to pick a different name for it because he can no longer operate. So everybody still calls it MySQL.
But it's actually.
But if you install MySQL, the actual MySQL, you're going to get a butt-old version of MySQL that is not compatible with anything that people expect. So the new thing's called MariaDB.
Yeah.
This is kind of like OpenOffice became LibreOffice, but it used to be StarOffice. It's that kind of thing. It's just trademark.
Libre, or one of them is gonna start charging.
Well, there's a third one
I swear.
now.
I swear, they're making like a different branch that's gonna be monetized, basically. I forget which one it was, Libre
It's
or.
amazing how often this seems to happen, like just the longer you go, people are like, hey, I need to make money. We built all this good stuff, we should start charging. And people are like, I don't like that you're charging, I'm gonna take the old code and open source it and build this. And then they end up,
I think AJ puts it down to where like the reality of open source software maintainers is that you're barely getting by to create software that people make millions of dollars off.
It is, yeah, people, I've written software that has saved people literally, I would imagine that it is in the hundreds of thousands. I would not be surprised if it's in the millions. And I did a Kickstarter and got $5,000. So, not gonna do that. Well, I didn't do it I did it because I needed it at the time. And so, anyway, but it ended up, it's ridiculous that I wasn't able to find a way to monetize it because I should have been able to make a living off of it. But whatever. And I know other people that are in the same boat. They have software that's used at Google and, you know, well, this happened with Node. Node was renamed to IOJS for a little while because Joyent bought the trademark and changed it from Node.js, meaning Node JavaScript, to literally the trademark application says Node Joyent Smart. And if you look at the bottom of the Node.js website, you will see Node.js used by permission of Joyent because Joyent now owns the trademark. But what happened was Joyent bought Node for all the hype, like many companies do, didn't actually have that much interest in maintaining it, and didn't have the funds to dedicate, or didn't perceive themselves as having the funds, because how many people do you actually, most open source projects are run by 2 or 3 people, you know. But anyway, and so they forked it, and it was called IOJS for a couple of years, but then Joyent released the trademark back to essentially IOJS, and then they renamed it Node, and then they called it the Node Foundation, yada, yada, blah. Anyway, that's kind of off topic of the whole database thing. But I want to get back to the question, specifically what's different between SQL Server, which is Microsoft SQL, or MS SQL, those two are the same thing. MySQL, which is also MariaDB, those are the same thing, and Postgres. Specifically, the differences are how you show tables. MySQL does it the smartest way. It's called show tables. Super easy to memorize.
Yeah.
No one ever complained about the way to show tables in MySQL. In SQL Server, the way to show tables is you have to select off of SQL Server.system.objects.tables or something like that, which is just obnoxious, and that's the most difficult one. And then in Postgres, it's \D is how you show the description of the database, and then you can give it a table name and everything. So, and then I think the use statement is the same across all of them. I think in all of them, if you do use in the database name, am I wrong on that? Is SQL Server different?
Well, doesn't Postgres do \C?
Oh, never mind. Okay, so yeah, so how you select a database, how you select any of the metadata, how you do permissions, the users, the row level access, anything like that, that's all different. Every database now supports JSON columns, the SQL databases. I don't think that any of the SQL databases don't support JSON columns at this point. But JSON columns just means basically it does a little bit of fancy indexing on the columns so that it's not so expensive. So it's called a full table scan when you have to read through every single row in a database. If you can't do a binary search to get to the specific one within just a couple of operations. And so the JSON columns, what they do is index the data by the key value pairs. So if you want to get something specific, I think it can index it, and at the very least, it doesn't have to do a whole scan of that field or that column when it gets to it. It can go specifically to the piece of data that's right there, so it gives it more efficiency. But it's not as efficient in the general cases, maybe doing a join depending on what the type of data is. If you have just an array and it's an array of strings, it's probably pretty darn efficient. But if you have some sort of complex JSON object, you're probably slowing the database down. And then the other thing that's different is the quotes. So SQL Server uses square brackets to quote things. MySQL uses backticks to quote identifiers, and strings or backticks to quote values. An identifier would be something like a database name, a table name, a column name, and then a value would be something like the number 7, the word hallelujah, the time 7:40 p.m. And then Postgres uses single quotes for identifiers and double quotes for values, unless I'm swapping that, in which case it's double quotes for identifiers and single quotes for values. And then, as Jordan said, the differences in the performance are nuanced between the different types of indexes that are available to you. And there's different types of indexes. Every database supports multiple types of indexes, and their indexing algorithms are semi-proprietary, meaning that they're at least specific. They may be an open standard, but they're specific to that database. But generally, they're based on well-known algorithms that you'd learn in a computer science class. So they're based on binary search or B-tree or red-black tree or something like that.
How hard would it be, like, say you started a project using MySQL and you wanted to switch to Postgres? How hard would it be to, like, convert everything over?
Do you want to keep the data or not?
Yes, yeah, well, yeah.
It's probably not that bad, especially if you're using a programming language that has any sort of abstraction over your database. If you're putting raw SQL strings in there, you may have to fix it, but if you got, like for example, the differences between selecting databases and tables, usually in any programming language, you're going to have some sort of connection object, and you do like .db and give it the DB name, .table, give it the table name, something like that. So there's relatively, and that'll often be the same regardless of what backend you're using. So a lot of times the abstractions in your programming language library will paper over some of it, but
Gotcha.
pulling the data out and getting it back in, the formats are going to be slightly different. Be a thing. But it's not the end of the world.
If you're writing your own SQL, then you should probably rely on find a library to do that. Like, lots of frameworks do it for you. So like Laravel, I know you said you work with WordPress. I think WordPress has a query builder. If you're using those and not writing your own SQL, then I mean, like you said, it would be pretty painless because you just switch the connection type or where it connects to.
And then that framework would kind of handle like the differences between the languages, right?
I don't know if
So,
it would
well, I
handle
mean,
transferring the data between databases, that's why
Oh,
I
is that
asked, is
Oh.
you could very easily, like, I mean, especially if you're using Next or, Objection, I think is built on top of Next. And
So I put up on the
Yeah.
screen here, Connects.js. This is,
Yeah, so,
Is it
so like,
Connects? I
like
don't know.
Laravel.
I call it Connects.
I think WordPress might have its own migration part.
We don't
but
use
that's
WordPress and
exactly-
JavaScript Pro.
Well, he mentioned WordPress.
Oh,
Yeah,
that's-
not very much of it.
That's true.
Trying to get away from it, so,
Yeah. Well, you can make a lot of money on WordPress.
Yeah, there's tons of work
yeah,
out there.
if you don't fall asleep while you're doing it.
Well, there's plenty to do
If you don't have a soul anymore, you'll be fine in
Yeah, you'll be
WordPress.
fine with no
Yeah.
soul.
Hey, look, it has a pronunciation right there.
Connects.
Connects.
Wait, so
Okay.
what is this? What
So
is-
I actually did pronounce it correct.
Yeah.
So
I
Connects,
pronounced it wrong, sorry.
Connects is a query builder. I should show you what that means. Let me bring up a good old fashioned terminal here. Let's bring this up.
So,
Ooh, I can see it.
Jeez,
we can discuss this later, but I did wanna talk about,
huge.
like abstractions like Objection versus Mongoose. Like on top of either NoSQL or Postgres and stuff like that, like any opinions on that, like what type of, do you prefer straight up SQL in your node, or do you prefer, like a schema validator on top of your database requests and stuff?
Sorry, I actually was, you were looking at me.
Focus.
Were you directing that question to me?
Yes.
So I looked away and
Yes.
started doing
You're
this to
good.
be able to show the Connects example. And then I actually was not listening until I looked over and realized that you were not speaking to the group, that you had your eyes on me.
Yes.
So let's come back to that in just a
Yeah.
second. Let me do this Connects example while
I did preface all that with, we can talk about this after, so.
Okay, cool. That's great.
I
That's
like
great.
Mongoose. I like using Mongoose.
See, I do
It's
too,
pretty
and
simple,
I'm
right?
most
Yeah,
familiar
and I don't think
with it.
complexity makes it better. I mean,
Okay,
Or
let's
Mongoose is
see.
the library, right?
it's just the library on top of Node.js, yeah.
So you can do like select and then join and locally join.
Ah,
Don't say join in Mongo.
Yeah, so-
Yeah,
No, 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 no.
In place of join support, it just doesn't work in any real database.
Well, I've
There
seen
you
like-
go.
I've seen like people do almost like foreign keys within a,
You
you
can-
Yeah.
point to another.
Modern versions of Mongo can do joins if, I forget, one of the two collections has to not be sharded, which I feel like, unless you're playing around, the reason for running Mongo is that you shard and spread it out over a bunch of machines.
No, right.
So you can't do any joins that way.
Does shard mean distributed?
Yeah, so this is where I feel like Mongo has a better scaling story than most of the out-of-the-box SQL databases.
Uh-huh.
That's because if you're using something like Postgres, if you want to shard it, put like half your users on one database server and half on another, you almost have to do a client side. You have to say like, hey, am I looking for, A through K users, or the rest of the alphabet. Mongo has the concept where you can say, here's my shard key. So for users, my shard key might be their user ID or might be some arbitrary identifier, who knows what. And then it will break your data into chunks and it will distribute them among the shards that you provide. And then you have a query router, it's just actually a separate process, MongoS, that when you issue your queries to it, and it figures out which shards it needs to talk to get your response back.
Okay.
Wait, why would you wanna split it in the first place? It just seems.
So like, for example, our database peaks at about 30,000 writes a second.
Okay,
I don't think I can do that on a single Postgres or MySQL node.
gotcha. So if you have a lot of writes.
Yeah, I mean, we run 16 shards, and these all have a quarter terabyte RAM and
Wow,
60 cores or something. So
and it can't.
it would be, like, if we wanted to get a machine that was as powerful as all this together, that would,
So that's
that's
good.
like a
It's
supercomputer.
like an AMD Threadripper. Right? With like the 64 cores and.
Yeah,
So the nice thing is, you can easily just add a second machine, and assuming you didn't make any poor database decisions, you effectively get twice the scale out out of that.
So
having
it's
two
a,
machines.
it's a hardware limitation.
You kind of just tell the other shards or clusters, like, hey, there's a new shard, and it'll kind of.
And migrate some
manage it.
pieces over
Yeah.
there until the data's even distributed.
I kind of have a question. Have anyone used? Has anyone used GraphQL?
Yes. Well, I'm learning it right now. But
So I was gonna say, what do you think of it? Because I just started kind of playing with it today. At least for building users, it's basically for a blog site. So building users, handling comments, handling, I don't know, posts.
I hate it, but I hate
For
most
that,
things from
it's
Facebook,
perfect,
so.
man. For that.
I mean, it's
Okay.
cool to like compose like
Thanks.
that.
Like I'm not gonna use it for anything super complex, but I don't know.
Yeah, I liked it a lot. It's really simple, straightforward.
Okay. I like the way you query stuff.
Yeah,
Yeah,
it's
that's
straight to
cool.
the point.
I feel like it's harder to set up initially, but it is cool once you have it.
GraphQL, like Mongo, it creates a new market opportunity. This is why it's gained favor. Because you could say, hey, let's not do REST like an idiot. But then you have to define what not doing REST like an idiot is. And so instead, they created GraphQL. Because we could have all the same tools with REST, but somebody would have to pick a side and say, this is the flag in the ground of how we should do things, and then you'd get bickering and arguing. So instead, they just created different technology. So GraphQL is really awesome on the front end because of all the auto-completion that you get with the debugger. The debugger is what makes GraphQL. On the back end, it is a flipping nightmare because you basically can use Apollo or you can hate your life. Which, if you're in Node, then you probably want to use Apollo, and that's fine, but GraphQL is a standard. All the things on the conference slides only apply to Apollo. They don't apply to GraphQL, generically speaking. Front end really awesome, back end really terrible. When you speak to back end people, you're mostly going to hear that they hate GraphQL. When you speak to front end people, you're mostly going to hear that they love GraphQL. Because GraphQL on the front end is just magic.
Yeah, so it's like, it's magic, but then you look at the, what was it, the computational complexity that it introduces to do simple stuff is just, I mean, like I said, for like a block site and stuff, that stuff's really cool, but I don't know how well does it scale.
Well, you can get, I think there's one other thing that works well with GraphQL. I think there's a PostgreSQL. It's Postgres and GraphQL, and it will optimize your queries. Because it picks a specific one database, and everything's supposed to work that way. But then when you try to do authentication and stuff like that, then it gets hairy. Because then you gotta write all these custom hooks and everything.
As I say, having not actually used it, just people talk about using it here, and we've got a lot of microservices which currently return the responses to REST requests. And writing a service that parses GraphQL and figures out what microservices to call and collect data from, put together, feels like a very large proposition, especially if you want to do it well.
Yeah.
Whereas
Okay.
if all of our data was in one database and we had a tool that is designed for optimizing queries for that database based on GraphQL, that would probably work great.
Well, but the problem is that on the conference slides, they advertise GraphQL as being great for stitching APIs together. But it's not as good as just regular Node in terms of being able to understand it and produce outcomes. I think Node is great for stitching APIs.
So is GraphQL's like draw that you can compose stuff without being able to change a REST API to just return the exact response that you want?
Oh, sorry, say that again?
So the GraphQL's like the reason people use it is because you can compose different parts of a REST response without actually having access to the server to write the exact response that you want.
Yeah. So selling points of GraphQL, magic, okay?
I'm sold.
But no, the selling parts are, one, you get TypeScript auto-completion on the front end. So you get your typing, you get auto-completion, you get a debugger. That's awesome. It actually is awesome and valuable. Two is a completely bogus mythical idea. Maybe I shouldn't prefix it that way. But two is the idea that you're going to be able to consume less data from the server and that you're going to be able to pare down so that you're not getting a bunch of data that you don't need. But this argument is bogus because only if you are a really, really good engineer about how you define your data does that ever become true. I never see anybody actually use a caching layer with it correctly. I don't see, so the problem is, when the user logs in, you should fetch the data that the user needs for that session. And some people that are hardcore on the Rails style REST philosophy argue vehemently against that. And I don't know why, but that's what needs to be done. When the user logs in, fetch the data that they're going to need for the session, and then fetch the other data they need as you need it. If you do that, then you're going to have a fairly good time and you're not going to have a bunch of requests. The way that I see people use GraphQL, they still have just as many requests, and then they request the same data over and over again because they're optimizing by only requesting the data they need, but then making 100 small requests of only the data they need, where at least half of the data is in each of the responses. So, but that's the selling point of it, is that you're going to get this caching layer and it's going to be great, and that you're going to be able to select only the data you need and it's going to be great. Now, I think Netflix has a tool, I don't think it's actually GraphQL based, but Netflix has an open source tool that actually does this. I think it's integrated with Firebase. And I've seen the demo of it, and it delivers as promised on that it's got a great caching layer and it only downloads what you need. Why Netflix needs a tool like that, I have no idea. They're a scroll site for movies, but whatever.
How does GraphQL cache? Does it just go based on the cache control header, or?
No, you would have a caching layer in your application, so you would get a React GraphQL cache plugin. But the idea would be that you could fetch only the pieces that you need. When you were missing a piece of data, you could just fetch the pieces that you need and then have it pull in and get it. So the other selling point of GraphQL is that you're going to be able to stitch microservices together. So we live in a world of graph data where there's users and users have relationships and so on and so on and so forth, right? And so, that's fine, I guess we can do that route. Or we can go this route, okay. Anyway, so with GraphQL, the idea is that you're gonna optimize your experience around these little microservices. But in reality, like what Will said, you end up introducing these cycles where you're making calls to a service order n squared times. So you need to get three user preferences instead of making a request that's optimized to query that API like you would if you were building it by hand. You're going to get generated code that's going to end up querying the API n times. So if you need to get n users and then you need to get n users' friends, you're doing n squared queries. So if you drink the Kool-Aid 100%, which if you're going to go GraphQL, the only way to go GraphQL is 100%. Because if you don't go 100%, then you end up with a really junky solution. But if you go 100%, you go Apollo, you go React, you go the caching plugin, if you just drink the React Kool-Aid by the gallon, you could have a solution as promised in conference slides that meets all those criteria. But if you take it piecemeal and you're like, oh, React seems like a cool idea, I'm going to build this one service, this one-off service in it, then you're going to create a nightmare for yourself.
So I was going to add a comment about at the company I was last working for. I wasn't actually involved with the GraphQL adoption, but they literally spent 6 months on it and then scrapped it because it just wouldn't work with how we were doing databases in .NET and stuff like that. And so they had this huge effort to GraphQL was going to solve all our problems. We're using React, exactly what he's saying. And then it's like, well, no, we literally have to rebuild all of this stuff to get GraphQL working the way we want it. And so it's like, if you're building all the servers from scratch, starting with GraphQL, you're probably good.
Yeah.
If you're trying to merge it into an existing stack, you're going to have the microservice, how do we build all of this stuff? How do we change all our queries to this? And then you're also you're running an extra layer because you're probably not going to scrap all your Rust servers. You're probably not going to scrap all the ways you're currently doing things. So you're going to have to sprinkle in the GraphQL magic. And so now you've actually added another layer of complexity you have to manage long-term if it gets adopted. And then it's like, well, no, our GraphQL layer broke, even though everything else is still working. But now these clients that only use the GraphQL can't work because we've got to fix this.
And if you look here, here's the GraphQL website. Notice what it's about. Describe your data, ask for what you want, get predictable results.
So I love GraphQL because of what it makes you think it can do.
But it's marketed to front-end
That's
people.
beautiful. Like if you look at that's
Oh,
one
yeah.
example. That is beautiful.
It's not how it turns out though.
Yeah.
If our backend magically supported GraphQL queries, then I think it'd be great for front-end devs to use it, because then they can specify the shape of data they want, the different pieces, there's a lot of potential there. The tough part is how the backend piece, and the query language isn't really what I want. If I'm running a backend service, I don't want to be like, okay, here's a big blob of text or something, I need to parse it, I need to figure out, I need a query plan now. It's one of the fun parts that databases have gotten really good at, is query plans, except for Mongo. Which is part of the fun. It actually, the first time you run a query, it guesses on a bunch of possible ways to run it, and whichever one's fastest is its query plan for the next 100 writes. So until you've written 100 more pieces of data, your data shape's basically the same, and so whichever one ran fastest the first time, it just keeps using it. It's pretty cool. Whereas like the real SQL engines, they actually have to do a lot of analysis to figure out, what indexes should I use first, Mongo just runs them all and picks the fastest and doesn't change.
So I'm kind of curious, like if you had to pick, I guess, 3, databases that you would have people learn, what would you pick?
Why would you pick 3?
I don't know. Just kind of, okay, so like out of most popular, because some companies are always like, I need
No.
SQL, or no, we need Mongo.
No.
It is gonna say Postgres.
Oh,
I've
so-
already watched this presentation
I am going to say
Utah.js from like a year ago.
I am going to say Postgres, but no. Pick a data. People think, oh, I'm going to learn technology and then I'm going to get a job. You don't learn technology and get a job. That's like saying, I'm going to go to an Asian restaurant and a Mexican restaurant and a Greek restaurant, and then I'm going to become a chef, right? You don't survey technology and get a taste, and then now you're prepared to get a job. You need to pick a focus. So if you want to be at Microsoft shops, if you agree with the Microsoft values, if you think C# is a cool idea, if you like the conference talks that Microsoft's putting out, then dang it, just go all in on MSQL and be an MSQL guy. Don't say, oh, well, because I don't know what kind of job I'm going to get and the universe is full of jobs, I'm going to be mediocre at as many things as I can. Right? That's not the way to get a job.
No, and that's, so,
Learning one dialect of SQL is just fine for everything. I mean, I know here,
Okay.
you use Mongo. Mongo in your resume is only a slight, like, oh, that's nice, that's a little extra positive. But we assume if you've used databases, like we can explain how Mongo does indexes. And we can show you how Mongo does a query, and you'll get the general gist of it. Mongo is especially weird as query language, but it's fine. Anyone can learn it. Same with programming languages, right? We do mostly Go for backend right now. Some older code is Python. If you know Go and Python, that's great. Most people coming out of school don't know Go. Often they don't know Python. Java's common. Sometimes C++, depends on the program. But and then in the industry, you might. I'm dating myself now. I learned C++ in my program, but.
I was looking at his tattoo. I wasn't actually staring at you.
So we don't expect people to know them. If you know them, it's great. It's a benefit. You'll hit the ground running faster. But if you've used 2 or 3 languages, pretty comfortable you can learn Python or Go. Neither of them is that esoteric. I feel a little different if we were doing Haskell or something, then I might have a much larger bias for functional programming nerves, because that's a way to think. But most of the languages that are, Go is a lot like C, C++, Java, C#.
I think you mean it's a lot like Python. You accidentally said all those other things because it happens to have curly braces.
Yes.
It is the spiritual successor to Python. It is in the documentation, in the conference talks, they say this comes from Python.
They do take a lot of Python, it's true. But yeah, so, I mean, that's the thing.
Okay.
So if you know MS SQL, like SQL Server, there's no reason why some places like, oh, we're a Postgres shop, sorry, we can't hire you. Like, anyone who does that is an idiot. That's
Okay, because
But here's the other thing. Why would you be applying for Postgres jobs if you're learning SQL Server? Apply for SQL Server jobs. This is the thing I think is the number one mistake people make, is that they take the spray and pray methodology of I'm just going to apply to a bunch of different places without even knowing what I'm applying for, and then pray that one of them will take me for an interview. Learn specific technologies and look for companies that need those technologies. Anyway, you ask your question or say your thing.
No, you're good. So I think that was kind of my thing, is that I've noticed. So I've been going to other tech colleges too, and they are kind of implying that it's basically we're gonna spread you with 10 different languages, 3 different databases, 4 different frameworks, and then you should be able to know them all enough to where you can get a full stack job or whatever you're trying to do. And I'm like, as I'm trying to teach this to people, I'm realizing that the more things you stack on top, the more complex it gets, and the more I have to know before they even try and write it. And so I guess I'm wondering, is that a good thing, or just sticking to basically like, JavaScript, MongoDB, and I don't know, maybe one backend language like
I think
PHP?
the best tool developers can have is neuroplasticity, so learning how to learn. If you're fine with just, like, I can figure this out, I'll be an intern for you, I'll figure it out, I'll write it, then you're headed down the right road. If you can learn a framework like that,
Mm-hmm.
just try to, it's like a metacognition thing, you just learn how to learn and enjoy learning.
Mm-hmm.
And so I think because of that, there's some value in learning multiple languages. The problem is, depending on the program, some of them seem to be very quick. Like, I know when I was in school, there was a class that was like a survey of programming languages. That was just to familiarize you with different types, but they didn't give you that class and go, now you're a software developer. That was like, hey, you know what, you've done 3 or 4 classes in C++ and data structures and object-oriented programming and all that. Here, let me show you some other stuff that's not like that. Here's Prolog and here's Lisp and a lot of weird stuff. So I think there's a point that you need to go deep on something, because I think learning a little bit of syntax in 5 languages probably doesn't help a whole lot. That would be my
It'd be better. It'd be better rather than wasting time on. Okay, today we're going to teach you all the weird things about how MS SQL is different or how MariaDB is different. Just say, okay, we're going to pick Postgres. Postgres can do just about everything that you want a database to do. I'll bring myself back over here for once. Postgres can do just about everything you want a database to do. It's got an event store. Now, granted, some of the stuff that it does, they're kind of crappy add-ons. Maybe they shouldn't have done it. But it has some sort of hook system so you can get notifications on updates. You can use Postgres for just about anything that you want to do. Postgres scales really well. Postgres as a protocol is probably the most popular database protocol. Every enterprise database has a Postgres adapter. So if you want to connect to Google, you want to connect to Amazon, you can use the Postgres libraries to connect to those. They use the binary protocol that Postgres uses.
Mm-hmm.
But the thing that's important about the database is not all the minutia. It's not the, okay, here's how you show tables in this, here's how you show tables in that. That's the annoying stuff. The important stuff is, here's how you logically break something down in a meaningful way. And I think the most important thing to do is actually the reverse. Here's why not to break something down. Because the reason that people hate SQL is because the way that SQL is taught is from a purist mathematical perspective that everything needs to be in 6th normal form. And 6th normal form doesn't exist. That's a joke. Anybody that knows databases, SQL databases would get that a little bit, but or not anybody, but anyway, on from the joke. Essentially, if you break everything down perfectly, then you're going to have a really slow, inefficient database with perfect tables in your chart of what tables should look like. But that's not the goal. The goal is actually to say, when can I not break things down? And only break things down when you need to, because you may have a bunch of stuff on your user object. So you have a whole profile piece on your user object where it has their age and their name and da-da-da-da-da-da-da. Basically, you just need to figure out, what do I need to search on? I need to be able to search by their email address. They may have more than one email address. I need to be able to search by their user ID. I need to be able to search by their display name, right? So I'm CoolAge86, CoolAge86@gmail.com. My ID is 1J57QRP, and I also have a secondary email address. So those are the things you need to be able to search on. So everything else could just go into a text column, and that would be fine. Your database is not, like, nothing bad's going to happen. But when people teach databases, they tend to teach them as okay, let's break everything down, and then it becomes too complicated. But if you do the too complicated part, and then you can break it back down to the simpler part, then you've learned database as well, so that's good. But it's a lot of burden on people to have them think about every possible use case of a data structure. It's a lot of trial and error, and you have to figure it out. And in the end of the day, you got to do the same thing with Postgres or anything else that you got to do with Mongo. You got to read all the records out of the database if you need to restructure it, and then read all the things back into the database. Mm-hmm. So to your point earlier, how do you transfer between two databases? You don't migrate between databases. You export all of your data, and you re-import all of your data. That's the realistic way you do it.
Now, AJ, you're missing with Mongo. You can just start writing different data and just hope that the other data doesn't make code along. That's the benefit of this.
Well, but in reality, you do the same thing in Mongo that you do in other databases. You read all the data out, and you read it back in.
Change it, yeah.
You write it back in. So I would say, I don't care which database you teach people. It should probably be either MariaDB or Postgres. It should probably be Postgres. If you're a Microsoft shop, it 100% should be SQL Server, no questions asked, because Microsoft shops are usually integrated. The boot camp is normally integrated from top to bottom. You're learning C#, you're learning TypeScript, you're learning SQL Server, you're learning the Microsoft stack. But if you're not the Microsoft stack, then you probably shouldn't bother with the Microsoft languages, because there's plenty of other jobs, and there's boot camps for Microsoft stacks. So
Okay.
Does that?
Yeah, because I guess, and that was sort of, so I took over the program from the previous instructor, and that's how he kind of taught it, was sort of, here's like 5 databases, and you're going to have to learn like how to write in each one of them. And then later on, if you want to go in depth, you can.
But databases sounds like a bad idea to me.
Yeah, it was a bad idea.
Because we did Postgres, we did MySQL, we did, I guess MariaDB or whatever. I thought they were different at one point.
Well, they're different. I mean, they're different software releases, but they forked off of the same code base. I don't think MySQL has actually done anything because Oracle doesn't want to invest in a.
And then we did MongoDB and Firebase. That's
Firebase is not a database. Firebase is an API. It's not a database.
Okay.
It's not a database any more than Google Sheets is a database. But this is something I would say, teach people to use Google Sheets as a database, because that is practical. Because when you work with customers and they just need something quick and easy, they need a CRM tool, dang, Google Sheets works.
I've seen that used, and I thought it was a terrible idea at first, but they were like, oh, the customer can see the data right there. I was like, that's pretty, that's
You're
pretty
not
ingenious.
having to export the data to then give to the customer.
And then having different versions, and version 5, version 6. Oh, that's not the latest one.
And you don't have to build out the interface for them. It is amazing. Smart people who are not programmers can work magic in a spreadsheet. I have seen spreadsheets that make my skin crawl as a programmer. But if you look at it, yeah, okay, cells are pixels. You can draw a picture there.
Yeah.
That works.
Yeah, I mean, I think so. I mean, a SQL database makes sense because there's so much SQL in the world. I think that
And if you know
Any
SQL,
any SQL database is fine.
if you know SQL, then going to Mongo is just going to be the what do you call it when you're pleasantly surprised but for the wrong reasons? When you first encounter Mongo, you're going to think, wow.
It is really cool not to have to specify a table schema. I'll tell you, like Mongo will create databases, collections, which is tables.
Yeah.
It'll create all that for you. The first time you're like, hey, I want to save this random JSON document. this random JSON blob to this database in this collection. It's like, sure, I'll create all that for you, done. No indexes, so that's a problem, but problem people commonly run into. It's nice and convenient, but yeah, I think a SQL database totally makes sense. I think there's maybe value in learning something else, but most of the other stuff is somewhat like a document database, that would be Mongo. I think, I don't know which one of the couches, there was Couchbase, CouchDB, and there's like, I don't remember
One
which
of
is
them's a
which.
service, one of them's a DB.
Anyway, so,
If you want CouchDB, here's what you do. You mkdir CouchDB,
you
And
just
then-
write JSON files there?
and then you take you follow the CouchDB documentation for creating the function, and then you just return from that function to a file. Because that's literally what CouchDB is.
So there's document stores, which just let you store typically a JSON style blob. And then you get the weird stuff, is really where you go beyond that. Like you get a Cassandra, is really cool if you need multi-master, configurable consistency in multi-data centers. But most people don't need that.
Okay.
You really have a real specific use case to be like, Cassandra is the thing for me.
You've got a money problem at that point, and yeah.
So, I mean, there's graph databases.
What about the database that runs in Python? I forget the name of it, but it's like integrated into Python.
Well, so there's also a class of embedded databases. So there's like SQLite,
Wait.
is typically used.
that.
So when I say embedded databases, you don't run a database server process that you talk to over a network
Right,
socket.
right.
You just embed the database engine and then it's probably file on disk. So SQLite is the most common to that. I
Okay.
think you can run MariaDB that way, but it's got a really weird license, so people stay away from it.
Okay.
NEDB,
Yeah.
more or less functions.
Yeah, I mean, and then I think there's a lot that are more like language specific. Like there's a terrible one in Java that's name's escaping me right now. Is it like hypersonic DB or something? Anyway, it's terrible.
So those
so
are.
there's a bunch of them go.
Do you recommend those for? Well, it depends on the use case, but say I needed a database and I'm not storing vast amounts of information. I'm just storing, I don't know, 10,000 records. Would you recommend using a database built in to some of these
It's
languages?
a lot simpler. And the main thing is if you're going to be single user, right? If you've got one
Okay.
piece of code that's talking to it, that's
Yeah.
fine. If you're going to have multiple pieces of code that want to talk to it, that's when you start running into problems because most of these systems don't let you open the same file for multiple processes and like,
Okay.
coordinate between each other. You have to
Yeah,
think
they leave the
carefully.
locking up to you.
What if you wanted to use Python
But I feel like I
both
can
for
run
your
one
back
process.
end and your front end?
You can't do that.
Isn't there a framework, I know, for Python that allows you to build websites or something?
So you can write
WebPy.
HTML. You can use a template library.
Okay.
But you cannot, there is no Python on the front end because
You can compile just about anything in WebAssembly these days.
you can't compile something that's garbage collected. Well, they've managed to compile Go, but that's because it does garbage collection in a unique way.
But isn't there a framework for Python that allows you to easily build
There's
websites?
a Rails for Python. I forget what it's called. Is that Django?
Django?
Yeah, Django is Rails.
That's
for
been
Python.
really popular from what I've
Oh,
heard.
shame.
Well, so there's been a resurgence in Python, which is very sad because of machine learning. Python was great in the 90s. Python was awesome in the 90s. Python needs to die. We have Go, we have got Go, and we've got Rust. So if you're in for machine learning, Rust is the language to learn. If you're in for doing backends or systems, Go is the thing to do. Python needs to die. But it had this resurgence because of all this buzzword crap around machine learning and all this. And all these libraries are written in C. They're not written in Python. They're written in C. Because Python is dirt slow. Well, they made it faster, but it's okay, it's dirt slow. We'll just go with that. But all the libraries for machine learning are written in C, and Python originally was more or less a way to write C faster. Python is a language on top of C so that you can write C faster.
So whereas C is a compiled language, Python is a interpreted language?
Traditionally, it's interpreted. There are not really any interpreted languages left other than Bash at this point.
Well, PHP.
PHP is not interpreted anymore.
And
Well,
JavaScript.
it's gonna get.
JavaScript's not interpreted.
No, it's
not?
No.
Lua is still interpreted, but even the big Lua
Compile on
implementations are
demand
now
or whatever.
Oh, okay.
So JIT means just-in-time compiled.
Oh,
So the
that's
difference
it.
between interpreted and
Just-in-time.
bytecode or just-in-time compiled is interpreted means it literally reads the file in one line at a time,
Right.
and it executes each line as it reads that line.
Right.
And the just-in-time compiled is it reads the file, and then after it's read the file as a whole, then it begins to execute it. And that's the way that JavaScript and everything else works these days. Is
Well, but
that
you're missing it predicts paths, like the
Yes.
fastest paths. So,
So it will compile the code.
Java can be faster than a lot of C because it has like the path determination that is like, oh, this is faster, or this is where I've gone, 9,000 times out of 10,000 times, we're gonna take this path. I'm
Interesting.
oversimplifying it, but
Okay, but C is a true compiled, not a compiled just in time.
Mhm.
no, yeah,
What?
C is compiled.
C is compiled, Go is compiled, Rust is compiled. And you shouldn't use C unless for some reason you can't use Rust or Go. And the same thing with C++. Generally, C++ people will go to Rust, and C people will probably go to Go. But yeah, compiled, the nice thing about compiled is that you can ship a binary that somebody can download and it can run all on its own.
Especially the statically linked, which is where I really enjoyed Go, because you don't have to worry about, for the most part, what's installed on your host system.
Right.
And cross-compiling is an environment variable change.
Okay.
It's really slick.
It sounds like compiled just in time and scripting, interpreted languages are becoming more popular. Is that a fair statement? But
They're all the same.
Or wait.
They're all the things that have already been.
well,
Which
okay.
is
So
becoming
it's
more
not like
popular.
one is becoming more.
No, they have different
with-
use cases, completely different use cases.
But with more web applications and front end type.
Well, what we've done is we're replacing the bad compiled languages that give us viruses, vulnerabilities, leak user data with safe languages. So whereas there was a time when people would write web services in C++, that's incredibly dangerous. Now we write them in Go or Rust.
Okay.
And I'll moderate EJ a little bit here in terms of, I think Python has its uses. Often it's fast enough for what you're doing, and it's a good exploration language too, which is why I like Python, the Jupyter notebooks and stuff, where you can type it a few lines, run it, and change some things around. I think that's where it's actually nice for machine learning, because you can play with things, see an output, and just change like a little bit, and just see what changing that step does.
Right.
And in many cases, it is fast enough.
But it
most
doesn't
things don't
scale.
actually- Yeah, most things don't actually have to scale. Is really the real, it's why we don't optimize things ahead of time. As my cool startup idea probably isn't actually going to get any users, so I don't actually need to scale. But if you do need to get to the point where you have to scale, Python becomes challenging, because usually you have to run multiple copies of it.
Okay.
Like we still have some Python running around, and there's some things we run 700 copies of, because generally Python's single threaded. There are some exceptions, but that's a different
Yeah. It's-
different minefield.
Hmm.
So we
Gotcha.
run single threaded Python, where you just run 700 copies of it.
Mm-hmm.
So now we have 700 threads. Great.
Wow.
Yeah, and Python, AWS loves Python because they are printing money on Python. Because if you want to do a machine learning process
Or
in
Java.
Python,
I mean, memory usage is memory's pretty expensive in the cloud. So
well,
Java-
that's what I'm saying. Is because if you want to do machine learning in Python in AWS, you have to take whatever your data size is. Say your data size is 5 gigabytes. You're going to need 20 gigabytes of RAM. Bare minimum, you will not be able to run it without 15. So whatever your data set size is, multiply that by 3, and you have to pay for that much RAM. And that's why AWS on the inside, everything's Go and Rust, or moving in that direction for what legacy code there is. If you look at their website, everybody that's doing anything cloud infrastructure, it's all Go and Rust.
Okay.
But what they want you to run, they want you to run Python, because they print money when you run Python.
Okay, I get your leaning now.
To cut their costs and maximize yours.
Right.
Yeah, I made a tweet. I actually made a tweet saying AWS hates Rust because Python is their cash cow. And then the person didn't realize that their response, so somebody from Amazon tweeted back at me and said, no, we love Rust. We're turning all our services into Rust. Like,
That's the point.
yes, yes. But you're not telling anyone else to. Yeah, two things you can do if you want to save literally hundreds of thousands of dollars for your employer. 3 things. This is something to make note of. Swap space, garbage collection tuning, and I don't remember what the third one was. But the people literally save millions of dollars just by adding swap space, which you can't do if you're using Kubernetes or Docker, typically speaking. But if you run a VPS, if you just add swap space, you can save hundreds of dollars per instance. Because with something like Python, if your data set's 5 gigabytes, it's only processing 500 megabytes at a time. So you either need to pay for a 20 gigabyte instance if you don't have swap space, but if you add the swap space and it's only processing 500 megabytes at a time, you can run an instance that's got 1 gig of RAM and then just add 20 gigs of swap to it, and it'll process in almost identical time. Because
What is swap space?
swap space is virtual memory.
Oh.
So it's
basically creates a file on the system and then tells the system to treat that like memory.
yeah.
And so it's
He means RAM.
RAM, yeah.
So it's like virtual RAM in a way.
Okay.
Uses your hard drive instead of your RAM.
Oh, wow.
Yeah, so if you were to do that with an application that actively uses, so if you pull up Activity Monitor on your Mac, for example, it'll have wired memory and resident memory. Wired memory, if I remember its terminology correctly, is what an application is currently using. Resident memory is the memory that the application has allocated and stuff may be there, but it's not actively using it. So on a process, if you need to do machine learning in Python, you're going to need 20 gigs of RAM for this 5 gigabyte data set, but it's only going to process 500 megabytes at a time. And so what it's doing is, it's already on disk anyway. The file's already on disk, right? So you're just saying make a copy of the file on disk rather than making a full copy in RAM. And then as it's done with the portion it's processing, that leaves RAM, and then it reads in from disk the portion that it is processing. So it's just, but it needs multiple copies when it's doing the calculations.
Gotcha. Yeah, thanks for explaining that. It's good.
Is there anything else we want to talk about databases?
I wanted to talk about the ORM stuff. Or
Oh yeah, we gotta talk about that.
Mongoose versus Objection. So I'm most familiar with like Node and MongoDB and using Mongoose for schemas. And so I've been trying to build a new service. And after the Fastify talk, I'm like, I haven't used Fastify, I'll try Fastify. So I've been trying to figure out how I want to arrange the data. And I'm like, do I want to use something like Objection to shape the data before I stick it into Postgres? Or should I just be writing SQL queries straight in code? Or, yeah.
Yeah, I definitely don't. If you're writing SQL, you're probably doing it wrong. I mean, no offense. You want to use a wrapper, and the wrappers, the functions actually look like SQL. So, I mean,
Yeah, and I've been poking around with Nex and Objection is built on Nex. And as far as I can tell, Objection just adds the schema compliance on, like, before you go ahead and, like, save stuff to the server.
Wait, so
So
when you
I'm gonna switch over to the screen here real quick because I brought this up earlier when we were talking about it first, and I think it'd be better.
yeah, so like you can chain all those functions together, and it still looks like SQL.
Oh, okay.
More or less, yeah.
Wait, so you want to do that instead of actually writing the SQL?
As much as
okay,
possible,
that's something I'm
'cause
not doing.
A library will like escape stuff for you to prevent MySQL injection. Or
Sure.
not
Well, you don't have to worry about
injection.
injection on anything that's modern though.
Yeah.
I know, but it sounds like they're writing their own SQL though.
Yeah, I am, but I am using, the
But you still parameterize.
Yeah.
You put a question mark or a dollar
Okay,
sign one.
yeah.
or a $1, $2.
Yeah.
Oh, yeah, so
Well,
you're
yeah, that's
in Postgres.
Yeah, well,
Okay.
it came from MySQL, but yeah.
But that's the third thing, or fifth thing, or whatever about the databases is parameterization. Postgres uses $1, $2. MySQL uses question mark. And I think that MS SQL is this, no, MS SQL I think is :1, :2 or something like that.
Wait, so what would you use with Node and Postgres?
So,
Is that what you're showing?
Next.
yeah, so this is what I'm showing. So with
Oh,
Connects,
sorry, connects. I keep saying, like,
Connects.
no, but, yeah.
So I've gone back and forth on this, and I've landed on lightweight query builder as my preferred solution. So let's say we're first. Oops. Actually, let me do this first.
So does connects qualify as a lightweight query builder then?
Yes.
Okay.
Yeah. So as you can see here, the difference between what I write in Connects, and by the way, Connects actually returns a promise.
Oh,
There we go. So it actually returns a promise, but it also has a toString method. So if you want to be able to just see, it needs some configuration to be able to know how to escape things. So you'll notice here, SQLite uses backticks, and I was going to show another thing about SQLite. I'll save that for later. But so here it's using backticks the same way that MariaDB does, and then single quotes for values, which, yeah, whatever. Anyway. I don't like that it doesn't output uppercase for the SQL, because that is the traditional way to do it, and I think it's the right way to do it because it makes it easier to read the difference between the identifiers, the SQL, and the values. But whatever.
Does it have a conversion to SQL, like instead of toString, is there a toSQL option or anything on it?
Well, I don't know what you would mean by that because the string is the SQL.
No, I just mean like maybe they have a formatted version of toString.
Well, let's
Yeah.
let's see what happens if I do. All right, I'm gonna do var x equals, and then we'll just do x dot and see what we get. toSQL. Well, I wonder what toSQL is. Yeah, that's not what I thought.
Wow.
That's not what I was expecting.
Well, that looks like an abstract syntax tree.
It
You
might
just
be.
broke it down, yeah.
It's got the bindings there. Oh, okay. So the difference is toString versus toSQL. toSQL gives you the bindings.
Nice.
So it gives you the parameterization, what the parameterization looks like, and this is typically what prints in the debugger. But anyway, this is my take on this. Why not use raw query strings? Because you get the full power of your database. I think I've already kind of said, you pick a database and you just go with it and you use the advantages of that database, right? You're not going to switch databases. And to the earlier question, if you have 10,000 records or less, just use a file. Anything less than 10,000, you don't need anything for it. Hold the whole thing in memory. I actually, there was a trick interview question once where a person asked me for a particular situation, and I said, well, I'm guessing that there are so many, they were asking me a question about dealerships. I said, well, I guess there's so many dealerships in the country. I said, I recently looked this up. There's 3,000 McDonald's in the country. I'm imagining there's fewer Toyota dealerships. If they each have 6 different types of car, that's less than 10,000 records. I would just store this in memory. I wouldn't use a database. And they said, you were the first person in 10 years that's answered that question correctly. The guy was actually looking for that as the answer. But anyway, you want to get the value where you can of your tooling. So with this, the main thing that you're getting is if you can, gosh, words. I'm going to stop for a second and then I'm going to speak and it's going to make sense. Okay. Your tooling can help you identify syntax errors here. So your tooling will let you know if you misspelled select or from or where. Well, if you're using some of the better tooling, the more advanced tooling. And the query builder will tell you if your SQL syntax is wrong and it will quote things correctly. And that's why I'd recommend using a SQL builder. Because if you do raw SQL strings, I don't know of any tools that can introspect a string. If you could put a comment above a string and say, if linter equals SQL, and have your linter and your tooling come back and say, oh, you have a SQL error on line 7 of this here doc string. then I would say, yeah, go all in on write SQL in your code, but there is no tooling I know of that can do that. And so if you've got something that can help you catch typos, because typing is the leading cause of typos, and you're going to do a lot of typing as a developer. So if you can do something to limit the number of typos and crappy mistakes that you make by using something that is tooling enabled, then do that. Just don't go overboard with it. But that's why I say query builders are great. When you get into the ORMs, I think ORMs are not so great. The reason for that, that's Object Relational Mapper. There are many ORMs out there because of open source projects. You got to think about it on this wise. If you're an open source project, what's your goal? Vanity. You want to get users. I mean, you could say you want to help the world, which might be true, but you want to see stars on GitHub. You know that database is the Postgres is the right database to use, so you're going to build out your project using Postgres. Everybody's going to whine at you and say, oh, well, I'm at a Microsoft shop. Why don't you support SQL Server? Oh, I can't use your great product. Oh, you suck. You know, oh, I'm a PHP developer. I always use MySQL. Why don't you support MySQL? Ah, you suck. And you don't want to hear that as an open source developer. You want to be told how great you are because that's the only compensation that you actually get for your work, right? So you want to use an object relational mapper when you're doing an open source project because you want people to tell you how great you are for letting them use their crappy database rather than the good database that you intended them to use. But outside of that, object relational mappers don't have a lot of value because they make everything more complex. They add another layer of abstraction between you and the data. They are less optimized because they're not tuned to a specific database. So if you have something that you're building out as a product or that you're working for a company or anything that's not open source, adding an object relational mapper adds overhead, doesn't add value, makes it more difficult for people that know SQL to work with the code, and since there's a million different object relational mappers out there to pick, no matter which one you pick, you're going to be wrong because nobody else is going to know it.
So ORM and GraphQL are the same thing?
GraphQL is kind of an ORM for APIs.
I've only really used two ORMs, and so I've been Hibernate Java, and the one time I had to touch some Rails code, and my experience with both of those is that you do one thing and suddenly, you know, you're like, I wonder what the SQL was for that, and it's like scrolling, and that's when you know you made a terrible mistake. That's funny. I think I tried to do some out, turn into 36 SQL queries. And so I find they abstract you a little bit too much. And if you're using it in a really simple way, like here's my person object, save my person to the database, it probably isn't that harmful. But if you're actually using it in the fancy features, they tend to get a little bit out of control.
And in JavaScript,
in
JavaScript in particular, if you're trying to use tooling, such, for example, I like using TypeScript not for TypeScript, but I like using the TypeScript linter on JavaScript. The TypeScript linter goes nuts on ORMs because it can't figure out what the fricky do is going on, especially with all the class inheritance that they do inside those things.
So SQL builders are preferred to just type in queries in SQL, like.
I would say yes. Database people are going to object because you lose the power.
Okay.
But at the end of the day, unless you're using Oracle, you don't write your application inside of your database. You connect to your database from your application. You know what I'm talking about?
my brother-in-law is
Entire
a PL/SQL developer at a normal shop.
There's
Yeah.
basically a WordPress built into Oracle.
So for connecting to a database, is that what we would call a relational database management system, RDBMS?
Relational database management system is any SQL database. There is theoretically another type of RDBMS that isn't SQL, but we don't know what it is. It hasn't been invented yet. Or I guess RethinkDB was that. But relational database management system is just an abstract term to mean a SQL database,
Okay.
but not necessarily a SQL database. Nobody can give you an example of an RDBMS that isn't SQL, except for maybe RethinkDB, but they don't exist anymore.
So there's also JDB.
But they came back.
That's the Java
Yeah.
abstraction over
Yeah.
databases. Yeah.
What about Microsoft Access?
That's a SQL database. Well, it's technically Access would be an ORM. because access goes between spreadsheets and SQL the same, but link is the ORM for access. I think they call it Microsoft Link, LINQ. It's a query builder, but it'll work on a spreadsheet or Access or MS SQL. But here's what Objection looks like, which is probably the most lightweight ORM for Node, and it essentially is just exposing connects with a wrapper layer that gives you. Maybe we can do some relations on here.
Lets you set up a schema,
Yeah,
which is what Mongoose does. So Mongoose does it for Mongo, and this does it for SQL databases. But yeah, AJ will probably be able to explain it better.
And we got somebody in the chat, Gillarn asks about NoSQL, so I guess we gotta go over that again sometime.
Watch the video of this.
Well,
No?
we didn't go over that much. We just had
Oh,
a
I
brief.
guess so.
I think it was in the pre-meeting chat that we talked about it, actually.
Yeah, it's just things that aren't SQL. I mean, was a blanket term. A bunch of NoSQL databases became popular, like Mongo. And I mean, I said Cassandra is a, I want to say it's column oriented.
I think so.
So there's a bunch of these like different formats. And graph databases would typically be considered NoSQL. But yeah, so they're just not SQL. And like I said, most of them are specialized. I consider document database to be the least specialized, because it's a fairly standard thing to be like, here's a sort of objecty thing I'm going to save. I want to be able to find them by some parameter. But you know, I said, like where Cassandra shines is this: I've got 4 data centers, and I want to make sure that I've got 5 Cassandra instances in each data center. I want 2 of them to acknowledge my writes and 4 of them to acknowledge my reads, so I've got very consistent reads. And I'm going to also say how they talk between the data centers, and like once again, if you need master-master replication, it can be really neat, but it's work.
Oh, side note, but I'm going to bring this up. This is the most important article that you absolutely must read. This is from early 2000s. Your coffee, if I could spell covfefe right, doesn't use two-phase commit. Anybody else know this article?
I just saw that.
This is one of the, I don't know, it's just one of the quintessential reads about databases.
It's not you, it
Are you're leaving? Are you up? Are you for more
is.
More Dr. Pepper? Could you get me more Dr. Pepper too, please?
You left my boss or something?
Give me more Dr. Pepper or you're fired. But I won't go into this too much. I always say that every time and then end up spending 20 minutes on it. I'm going to try to keep this to 2 minutes. When you make an order on Amazon, it doesn't matter. When you order a plane ticket, it doesn't matter. In many cases, the consistency detail that people want to really, really enforce if you're using SQL doesn't matter. Because you know what happens every year around Christmas? Anybody who has kids has had this problem. You buy something on Amazon, and then you buy one of the popular items that year on Amazon, and then what happens about 3 days after you make the order? Do you know?
Well, I mean, either they tell you it's delayed, or sorry, we don't actually, we can't fulfill that order.
Yeah, you just get an email that says, sorry, we can't fulfill that order. And what happens when every flight is overbooked by, what's the percentage?
I don't know, but yeah.
7%? Right, thank you.
Yep.
Every flight's overbooked by some percentage. And what happens when you get to the airport and you paid for a flight and your seat's not available?
Free money.
It just goes into a bidding war. We overbooked the flight. We're offering $500. And then they wait. If nobody comes up, they say, we're offering $500 and a free hotel stay. Then they wait. We're offering $700 and a free hotel stay. We're offering $700, a hotel stay, and a trip to Disneyland.
Deal.
But that's literally what happens. This has happened to my parents. I've seen it happen. I haven't taken the deal on it. But so a lot of times you got to think in your database, get out of your head with all the theories and get to the fact of the matter. Does it matter if this transaction is overbooked? We don't want to lose data. We never want to lose data. But if we get too much of a type of data, you just reconcile at the end of the day. Your bank transactions work this way. Most things in life work in this way where it doesn't actually matter whether or not the data is consistent, because some batch operation is going to run, and when the data is not consistent, they just say, oh, sorry. Somebody else wrote over top of your sentence in the document.
So would that be asynchronous or synchronous? I think it'd be asynchronous, right?
Well, yeah, it would be non-atomic. Is that the ACID is the triangle of the database?
Yeah, if you remove one item from your inventory and when you add one to someone's order, and you make sure that those two pieces only both happen or neither happens, that would, they have to happen atomically. So I think atomic would be the right one for that. And AJ's point is, if you screw that up occasionally, it actually doesn't matter in most real world circumstances.
Okay.
Yeah.
What was that article called again?
Your coffee shop doesn't use two-phase commits. And you can think of it as Starbucks model versus Walmart model. Walmart model, many registers running in parallel. Each one can only handle one customer at a time. Every customer has to wait in line for every item in each cart to be processed. That's Walmart. The way that you scale Walmart is you just scale out across the lanes. The way you scale Starbucks, you don't have to scale Starbucks because everybody comes up, gets their ticket, and goes and sits down, and then they get a callback. JavaScript callbacks. Node is only efficient because it follows the Starbucks model, which has trade-offs.
And 700 lanes at Walmart is how we run Python.
Yeah.
700 single processes that have to just do one step at a time.
These examples.
That's kind of how it is in a lot of scripting languages. So like people argue that PHP has threads, which I think it has a library that does it, but the classic way to parallelize PHP was to do fork and create a process. So you're duplicating your PHP script and the process that ran the script, which is basically what you're doing with the 700 lanes of Python. But there's not a whole lot of scripting languages that give you direct access to threading, because it's just, I don't know what I guess it's just too complex, but
Threading's fraught with peril, though languages like Go make it better. And Rust.
Okay.
I know there's that, I think it's Peter, somebody, he does a good video on YouTube about eventual consistency. And I forgot who does it, but he does a few different videos. But it was basically talking about like the likes on Twitter or something, and how could it possibly be correct all the time? It's a big one.
Yeah, so likes are not correct. They're just
No one cares.
Kind of was a question, sort of, for everybody.
I'll shut up if it's for everybody. Otherwise, nobody will get a chance to talk.
No, it's just sort of like, I guess in my head I'm thinking, so sort of about my program in a sense too, and sort of focusing on that single line where you're just focusing on getting good at one thing. And I guess I'm kind of wondering if changing out with our discussion on Python, is it better to go to Go or Rust over Python?
well, you don't want to ask AJ that. We already know what his answer is going to be.
Wait, what is my answer?
To go with Go.
No, it's not. Well,
Really?
okay. If you're teaching at a boot camp, 100% Go, no way Rust.
Agreed.
If you have, this is the thing, if you are trying to make the decision between Go and Rust, your decision's already made, you should be using Go. Okay. The reason is Rust fills a very specific niche. If you love it and you want to use it for things just because you want to use it for things, the world is your oyster. But there are occasions when Rust is the only solution, and that's when you use Rust. You don't typically, I would never advise someone to reach for Rust when Go will do.
Well, the cases are when your only viable options are Rust, C, or C++, and you
Yes.
realize that C or C++ are bad ideas, and you're better off using Rust.
I'm kind
So-
of wondering.
When you have to be low level, Rust does very well at that, as do C and C++, but Rust does it with far fewer footnotes. So C and C++, that you do all sorts of crazy stuff. I know in middle school I tried to learn C, and I initialized a lot of strings without actually allocating memory for them. You could just have a string pointer and just start putting characters, and it'll write over your next variable and probably eventually crash somewhere. You can do all sorts of crazy stuff, like without trying to. You know, with Rust, you have to be like, I'm going to go into unsafe mode because I'm going to try to do something intentionally stupid.
Well-
in C, you can just write to random. I mean, you can get an integer and go, actually, you're now a pointer to memory, and I'm going to write a string there. It'll probably blow up, but it might just overwrite something
What's the
important.
application?
Huh?
Or what's the question for?
I guess in the context of like, I guess more or less, should you learn Python? Because I notice like a lot of schools, again, kind of, they're pushing more toward Python, but I'm wondering if Go would be a better alternative and be more, I guess, kind of in a sense up to date and more practical for as like a backend language.
So
I guess
they-
is what I should specify.
It depends on what you want. What do you like? Do you want to make money? Like, do you want to get a job? Do you want to do you want to have a very performant
I mean, the
like-
goal is to give people a job.
Employment,
Yeah,
Yeah,
employment's ultimately the goal.
Yeah, because I mean, the Stack Overflow survey said that Python was the most wanted, like the people wanted to learn the most. The meetup for Python, I think, is the biggest meetup in Utah. I don't go to it because I don't see the need for Python. Like I'm wondering, like, what is Python so good at? It's good at transpiling. Python was pushed in school because they said it's an easy language
easy
to
to
pick
learn.
up, but there's so many problems with it in terms of like type safety and just
Well,
weird
it's type
quirks
safe.
on it.
That's better than it used to be.
Yeah,
Didn't you,
but it's
didn't you set type?
But I guess I don't understand. Like, I wouldn't be excited to learn Python just because I don't see how it's like the best at X. It's really good, I guess, at data science, like AI stuff.
But
that just transpiles to C. So it's like,
it's not that it transpiles, it's that it is using a C library and calling out to C, but yes.
yeah, it's basically using C. And so
The library was written in C, not in Python.
So, but the thing is coming into programming, you're like, oh, we learned Python in school. That's because, like, honestly, I think the teachers didn't know any better. Like, I honestly think they should have learned C or something, like C++ to learn, I think schools should be teaching Rust right now because it teaches a lot of low-level stuff. And I don't know, like, but the thing is.
But have you learned Rust?
No, I don't have time.
Well, the thing is, I don't know if I'd recommend that schools teach Rust depending on what it is, because Rust takes about 6 months to become fluent.
If it's a 4-year university,
Totally.
I can see the argument that you could have a multi-year.
Right.
If you're vertically
series.
integrated.
Yeah.
But not if the 100 level classes are in Java and the 200 level classes are in
Yeah.
C++ and the 300 levels are in C#.
Right.
If it's vertically integrated, I agree with you.
But my first programming class was in C++, and it was amazing.
Yep.
And the
me
teacher
too.
was good, and I loved it, and
Yeah.
it was
Okay,
at
cool.
BYU, Idaho.
No, actually
Oh.
out of state, but
Okay.
C++ was also the first one that I took.
Okay, because I loved C++. It was really good because it was low level, and it wasn't trying to do stuff for me, and
Yeah.
it helped me understand what was going on beneath.
Yeah.
And so something like that was nice for me. And then, I don't know, I don't see the reason for
I
for
think
Python. But I mean, like, I know I've talked to a teacher at a school that will remain nameless, and he didn't use GitHub. Like, and it was like, how, like, or he didn't use Git, like, committing and stuff. And I was like, how is, like, he's a PhD.
So,
And it's like, how did he,
That's the thing.
how
he's
did
a
he go that
PhD.
long?
Yeah.
you know,
Because
PhD.
PhDs do things pretty differently.
So
Yeah,
theoretically.
because that's what I'm saying is you get so far from your teaching and from reality of business that it just doesn't match. So
Yeah,
I don't know.
Yeah, colleges tend to lag the most
Yeah.
from what I've found in terms of being close to industry standards. Boot camps are somewhere in between college and industry standards because I think they're a bit more flexible. And in the boot camp I'm in right now, they're pushing Python pretty hard because it may not be the best. Like Go might be the best in some applications, Rust would be better in some niches, but it's all about employability. So
Yeah.
they're not teaching developers how to computationally do something most efficiently. It's more about how can we get the most grads employed. So that's why they're pushing Python.
When we
but this is the. I actually want to bring us back to the database and JavaScript discussion.
Sorry.
No, it's okay because we'll go down the rails here. But this is just a cyclical problem in the industry. It's okay. What programming languages work well and are easy to teach? Go, boom, right? And Python kind of sort of. But the thing is, people are hiring Python developers because that's what's being produced. People are producing Python. This is a negative, or I guess it's actually a positive feedback cycle.
It's a reason to write to if you have a small startup to do your code in Python because there's plenty of Python devs. That's what we're going for, and there's plenty of Python devs because there's enough jobs for Python that boot camps will teach it. And
But if you think about it, I would much rather hire somebody. You're just going to look more impressive on a resume if you're competing against people who are way smarter than you. Because there's not enough Go developers, right? So if you're a bad Go developer, first of all, Go makes it really hard to write bad code. I've seen people do it, but it's smart people doing it because you've got to be smart to write bad Go code because you have to know how to go against the grain and create anti-patterns. I've seen people do it, but you have to be smart to do it. If you're dumb and you write Go, you're gonna write good Go. So.
It's a better problem to have than the C problem of writing.
Well, a lot of like C and C++ jobs have ridiculously high barrier to entries. You got jobs with like Northrop Grumman where you're making real-time systems that you can't really make it a mistake. Like a lot of people can write Python more than they can write embedded C or C++. Because even then, like those embedded positions also force you to know like assembly language, which is archaic by modern day standards, but when it comes to hardware, you could save a company potentially hundreds of thousands of dollars by making your code efficient.
Well, Chrome, V8, so Node compiles down to assembly. It jits to assembly. That's why Node is insane. V8 has a lot of assembly in it. If you need it to be perfect, the assembly is the only way that you can go. But rarely do you need it to be perfect.
It also depends on if you're trying to. It really depends on what and that's what people hate to hear is it depends. I just talked to my cousin this morning about he wants to get into programming. What languages should he learn? I'm like, learn React and
But then you're competing against a sea of incompetence. And I don't mean that everybody who programs in React is incompetent, but what I mean is if you learn what everyone learns, it is difficult for an employer to distinguish you from someone who is good, and it is difficult for you to distinguish bad advice from good advice.
So you're saying
if you learn anything where mostly the people in it are good, you're going to have a leg up because you're going to surround yourself with people who you know are smarter than you. If you're learning Go or Rust as a beginner, you are surrounding yourself with people who are smarter than you, not people who are at your level or below it.
Right, and I was saying just from a front-end perspective,
Sure.
I think React is probably your best bet, is what I was thinking.
If you want a job yet.
If you want a job,
If you want to know what you're doing now.
The question is, how will you differentiate yourself? You go and learn React. How can you differentiate yourself? Even if you're actually in the top 10%, would the person interviewing you even be able to tell?
No.
But the alternative might be
I-
Go.
I don't know,
So if
dude,
you're
but-
using Go, they might be able.
But that's
What's that?
the thing, AJ.
Is that what
Would
you're saying?
what would you
Well,
say would be the
not
best
for
way
React,
to
that's
break
what I'm
into the industry if you're not in it? Would you say front end or back end? Because I think you're thinking more back end would be better.
This
I
is
do.
the Node.js meetup.
This is Node.js, but I do. I think it's better to learn the fundamentals of how the computer works, and then move forward from there. But then that's some of the other sentiments of this table. Like you like learning C++ because you like learning the fundamentals of how memory was managed on the computer and moving forward from there.
I don't know. I don't think anybody knows the mysteries of CSS. I don't think anybody can
CSS?
figure that out.
I love CSS.
Talk to me later.
I consider myself a full stack developer because I spent 9 years of VHDL and then moved up stack to the front end of writing Go and Python.
The problem with CSS is Safari doesn't do the same thing that Mozilla does, the same thing as Chrome. It's a mess.
So I don't want to open up that can of worms. I want to take us back a little bit. So
Sorry.
I'm gonna roll up the stack. So we went down the stack. I'm gonna wrap the stack back up. So we were talking about the Stack Overflow insights for the developer survey, and I don't know if they got the same graph this year that they had last year. Here it is. This is my favorite one. Look at where the money is. This is where you should be
Can
learning.
you bump the size at all?
Bottom's average years of professional experience.
I can't bump
I
the
guess
size.
that doesn't.
Okay, so down here is people that are making no money and have no experience.
Okay, so
Over here is people that have too much experience and aren't making any money. And then
Delphi.
over here is where people have less experience and are making more money. Look, Rust, Go, Bash, PowerShell, Scala, Julia. Okay, Julia for machine learning. Rust for machine learning and for embedded systems and for games and for a couple of other use cases, web services that are bare metal.
What's the one at the very top?
Clojure?
Clojure.
Yeah.
Okay. Yep.
So this one is a functional language, as is Erlang,
Am I
and
right?
as is F Sharp. So these people are getting paid the most money. They are all functional languages. They are getting paid the most money because it is very difficult to learn and difficult to understand, and they are very, very good at convincing people that for some reason their thing is better. But in some cases, it actually is better. There are some reasons why Erlang has remained in the marketplace, even though half of you at this table haven't heard of it, and it's extremely widely deployed because of how reliable it is.
I see Go on there. It's
Yeah.
So-
also pretty high.
Yeah,
But
so
then I
Go
guess-
is, but knows where Go is. Go is towards the beginner side of the spectrum. Now granted, this is average years of development,
10 years.
is 10 years, but the average starts at 8.
And
And
why
Rust
is
is less
that?
than 8 years old, right?
Because of the way that the survey is
Yeah,
structured.
isn't Rust less than 8 years
Yeah,
old?
but it's years of professional experience. I don't think it's like in that language. So I think it's the
I think
professional
they could be
experience
starting with
person
when you
survey.
started in high school or something too.
So look what's down here at the bottom. It's kind of sad that Dart loses out to
I
PHP.
don't know. I still
Delphi.
see more use in PHP.
I'm
than
surprised
Rust.
COBOL isn't higher up there. I'm really surprised about Crystal. Crystal is the one that's most surprising to me.
Yeah.
Crystal is Go with Ruby syntax. I'm surprised that
Is it actually built on Go?
it might be.
I didn't think it
remember.
was, but I could be wrong.
There are,
Here's my only wrench in this is that yes, those are high-paying jobs, but how many do you see on a job board for those?
There's also probably only like 5 Crystal developers, so that's
You're
the
not
other
gonna
problem.
get-
It's not very
Yeah.
popular, so that
Because
data
it's
might
very
just be
niche, so you have
spurious.
to really like find that job. You know?
we live in a tech hub. We literally live in 100 miles of interstate with business parks every 5 miles.
Yeah, but I don't know. I know it's sometimes hard to find Rust jobs. Like they're not.
Is it? He's hiring.
Yeah, my team only does a little bit of Rust, but we've got at least one all Rust job that's open.
People that want Rust jobs are now getting Rust
We
jobs.
do it for person detection on our cameras.
And by the time, and the other thing is, if you can, we talked about this before, if you can learn one language, you can learn another language. If you learn a language, you want to go where the ball is going, not where the ball has been. You want to predict where the ball is going, you learn Rust. Set your sights on, I'm going to build my career around Rust, right? And then maybe, yeah, you get a Python job, but you're going to be one of the better developers in that space because you've been surrounding yourself with better developers, right? and then you're still sticking with where the ball's going, and when the opportunity opens up, you can jump on it. But I'm very much against the cookie cutter idea that you blanket fire to a bunch of jobs. I say you come to meetups, you learn things you're interested in, you talk with cool people like Jeff that are hiring, and you get on their team. You're not here because you want to be generic cookie cutter people. Well, maybe you are. And that's okay if you are, because a lot of people are that way, and that's fine. But you're doing something that's not cookie cutter, because where are the other 700 people? They're not here tonight.
Yeah.
You've got an edge over everybody else who's applying for a job because you've got people that can vouch for you because you're making smart comments. And everybody in this room knows you're more intelligent in coding than most of the other people that they're running into. Not because you actually are, because maybe you aren't, but they know it because you said it and now it's in their head. You're a face. What?
Just have the earpiece.
You lost all credit.
I've been sending them all the answers.
There's a guy in the van.
I wonder if that'd be like a business idea, like, whispering smart things to say in meetups to someone who's trying to get a
That's
job.
literally every TV show and
Aw.
movie.
I was gonna say, I haven't heard any smart comments, only smart Alec comments.
No, he's got a lot of those, but you got a lot of those too. But no, he has made smart comments. Like at first, I thought he was just a wise guy, but he's actually over the time that he's come here. Anyway,
He's
so
dumb.
I'm going to close out this tab about so in async databases, async is called eventual consistency. It's not called async. So back to your way earlier point, database terminology, eventual consistency, async.
Okay.
There's different terminology for programming language and databases. Okay, we got out of that. We got out of this one. This was objection. This was, if we want to look at, this is also simple, which is good.
Yeah, it's Buffalo.
I'm trying to look for something a little bit more complex, but objection is very simple. That's one of the reasons I like objection. What's the other one? That's
Where's the schema examples of this though? I guess that's the,
models right here.
yeah, there you go.
Models. So I don't like this because they use classes, and as you know, I was going to talk about classless JavaScript.
Mm-hmm. This is why I brought it.
Okay, well that's fine. It's just this is complex.
Fair.
So for those of you that don't know, this was not originally part of JavaScript. Well, it was in ECMAScript 4, but Microsoft pushed really hard to get TypeScript adopted into JavaScript, and they have been successful to varying degrees. So this is essentially C# syntax, and I don't think it's a good fit for JavaScript, and blah 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 blah. But for another day. But it works, so we'll go with that. But this is what defining the model looks like in Objection. And there's a lot of good things here because it serves as documentation, is how you expect things to work. So it serves as documentation for how objects are nested. It serves as documentation for what the relationships are. So there's a lot of good things about using an ORM. But the problem with ORMs is I think that connects is something that you can pick up in about 15 minutes. If you know SQL queries, you can look at connects and you can start to predict, even without autocomplete tooling, you can start to predict what you need to type out and start to be correct. Maybe not 15 minutes, maybe an hour. But you use connect for several queries, or sorry, connects. You use connects for several queries and you get the gist of it, you get the sense of how it works and how to construct almost any SQL query. With the object relational mappers, when you get to doing the through relationships, you're adding more layers of terminology because it's not stuff that's in SQL. There's no such thing as many to many in SQL or belongs to in SQL. None of that exists. It's abstract concepts. And so you define those abstract concepts here. And it's great because it serves as documentation, but it's not so great because I don't know how this translates to SQL. And sometimes things are confusing because they're not what you think. For example, belongs to means that a table contains an ID and it can only relate, a foreign key ID, and it can only relate to one other table. Whereas a many-to-many has a join table, and then a belongs to through, then it just starts to get confusing as to what the tables look like. The logic is clear to me, at least. But the implementation of what it's going to look like in SQL is not clear to me. And so I find oftentimes when I go to an ORM, I start battling with the way that they term the through and the belongs to and the has many and the has one. You know, what's the difference between a has one and a belongs to? I guess they're inverse relationships. It's just, They're nice because you get all of these methods on your objects, but again, I was going to talk about classless JavaScript, and so I don't think that you need a bunch of methods on your objects. I don't think you need a dot save.
Wait, so how is this different from connects?
So
It's built on top of Connect.
it's built on top of connects.
Okay,
So if I go back here, let's bring this one back over.
something else.
So, well, every,
Well, connects
Connects
is very, very simple. So take a look at this. So this is what it looks like to configure a MySQL database. This is the only thing that's specific to MySQL. Just those lines right there. It's the connection strings, essentially. Here's how you connect to Postgres. Here's how you connect to SQLite. By the way, if you were going to pick just one database to do, I wouldn't fight against SQLite as opposed to Postgres.
Okay.
The reason being that it's so easy to start learning, and I was going to bring this up earlier, but there's a lot of myths out there about SQLite. If you can do 4 million queries per second on a single server with SQLite, these people chose Expensify. They chose, rather than using a scalable database model, they said, we're just going to vertically throw more power at the problem. And they made a couple of changes to SQLite that I believe they describe in the blog article as having made it into core. Then you can enable a couple of flags. But here's they put their statistics here and stuff.
Those
about-
bare metals cost like $8 an hour to run, don't they?
Well, unless you buy them. Well, yeah, to rent them, yes.
Yeah.
Something like that.
Oh, I thought that this is versus EC2. I was thinking bare metal on EC2 is what I didn't read right.
Yeah, if you have your own server rack or something in your house, that's could be bare metal, but
Yeah, so this says it costs $26 per hour, meaning $233,000 per year. But then I don't know where they give the actual expenses, but I think what they're going to say is it costs $30,000 for them to buy the servers. I don't know where I don't see that number in here. But what they're saying is that AWS rakes you over the coals.
Agreed.
It gets very expensive.
Yeah, they don't say what their cost is, but yeah, if you think about this, it makes sense. It is cheaper to run your own hardware, and it's easier to scale your hardware vertically. So
as long as you have the technical expertise, you're just
Yes.
You might be trading costs because now you have to hire developers or engineers who know how to scale that for you. But yeah,
but if you're at the scale where you're paying $230,000 per year,
you
can
have the
hire
money.
that person.
You can literally, yeah.
So that's the cloud is extremely expensive. People don't realize it because they think it's free, but that's until you use it, and then it costs 10 times as much as it would cost otherwise. But
Yes.
yeah, anyway, so this is SQLite, and this is Postgres. So anyway, the connection strings are pretty darn simple. They give you a couple examples here, and then after that,
Everyone's
nothing is specific to the database. Everything is just SQL queries. So how do you do a select? How do you do an as? How do you do from? How do you do where? How do you do where in? How do you do where not in? So this is pretty good at teaching you SQL as well. I finally cemented in my brain, well, I won't say cemented because I don't know if I could rattle it off right now, but the difference between a right join, left join, inner join, outer join, full join, and cross join.
Are those yoga poses?
They are also yoga poses. Yes, thank you. But yeah, so I think Connects is a pretty darn good way to go, and there's several different libraries use Connects under the hood. Objection, I find to be, I'm not saying this is a pun, so please don't make the pun about it unless you really need to, but I find it to be one of the least objectionable ORMs to use because it is quite simple and fairly straightforward, and it doesn't add too much layering, and it integrates Connects really well. So When you need to just use connects from Objection, you can. And although I don't agree with the way they did classes and it makes some of the tooling really confused, it is readable and it serves as great documentation. So there's that. Other thoughts on ORMs to use in Node? All right,
I
maybe we should-
investigated type ORM, but I hated its face. And there was one other I tinkered with and wasn't really caring for it, but I forget what it's called. Yeah.
Anybody else?
I was just gonna make a comment. All I'm gonna say is thank you guys for letting me ask questions in regards to kind of the sort of broad questions, I guess, in regards to programming, what languages, what stuff like that. Because I'm not just looking for other students, but myself as well, in kind of areas that I want to eventually go, which ironically one of them was Go, because I do have a friend who's a developer. I think he works, I want to say he works for Apple now, but he was doing Go for a long time.
So I'm, and thank all of you that contradict me because I have strong opinions and sometimes they're wrong or ill-informed. So
They're never wrong, they're just different.
So Prism is the other ORM that I looked into, and I actually liked it because it works with SQL, and I think you can plug it into Mongo.
oh,
It seemed
I
cool.
heard about this one a long time ago.
But I could not, you can't, it doesn't make it easy to deal with user
Is it
passwords.
Prisma or is it Prism?
Prisma, maybe. That might, yeah, that's it.
Okay, I think I would be strongly against anything that tries to integrate tons and tons of databases.
Yeah, it kind of seems like a
Oh, sorry,
GraphQL
Postgres,
thing.
Mongo, oh, okay, yeah.
I like that it kind of defines the schemas and generates the tables and does migrations and stuff, but then I started to build an app where I just wanted to encrypt the user password, and they don't provide any examples of how to, like, make a user authentication system and not have the password go through everything in plain text.
Well,
So I'm like, I could
that's-
encrypt
you
it
could
on,
just-
in the code, but there's other ORMs that, like, you can define something as a password so you know in the ORM,
They'll
like,
give you an
this is
example.
sensitive data.
Yeah, that's typical. Yeah, that's a typical example. Is to say the salted password hash is kept from the JSON, which is another thing I was going to bring up with the classless JavaScript. Is the whole most of what we want to do in JavaScript is JSON. But again, I'll save that for next month. I'll actually do out the slides now that I know that I'm going to present on it. Whereas before I was thinking, oh crap, I got to find a presenter, and then I just didn't. Yes.
So that other thing you said about objection, JS, like how you were like, yeah, some of the things are not like understandable why they call certain methods things, you know? So important because like I'm wrestling with AWS and it's just like,
What
Just-
part of AWS? Because that's literally
yeah, that's true.
hundreds of
It's
different
just-
products.
Just
Probably
with
thousands.
just with S3 right now, and just like a Cognito and authentication, and just doing some simple things that are missing from the API. You know, like you have to literally like there's a Stack Overflow question. It's like, yeah, I had to guess how to put in credentials for this thing, basically because they didn't cover it on the documentation. You know.
By the way,
So when you have good documentation, that can really drive a thing really well. And so when things don't really match, and it's like, why would you call it that method? It can really slow you down. Like you can get stuck on it for a while, like for when you're developing.
I do not like AWS's naming of things. It's like.
well,
yeah.
but they're smart because they pick things that get good SEO. They pick things that are extremely unique, that are short, that are incredibly brandable. The people that named the stuff at AWS did a bomb awesome job.
I mean method naming.
Oh, sorry.
Like,
It's all auto-generated.
It's awful, and it's.
No, all of their stuff is auto-generated because they target multiple languages. So they write in some sort of meta language, and then they auto-generate code. And this was another thing I was going to go into the classless JavaScript. Actually, was yeah. But they auto-generate, that way they can auto-generate the Go code and the Node code and the Java code and the C# code, and everything goes out at the same time, and they can auto-generate all the typing objects, and you know, so that's why it's the names are so terrible, is because they're auto-generated. But so one note I was going to say, if you want a nice way to interface with S3, this is the library that I wrote. As you can kind of tell, I don't use anyone else's dependencies for almost anything. I write almost everything myself. I started out as a young person realizing that it was better for me to use other people's stuff because they knew more than I did. And so if I learned how they did it, then I would benefit from their work and their knowledge. But at some point in the middle of my career came a turning point where I realized that at the point where I'm having bugs with other people's code, it would be better for me to have anything that I'm going to use multiple times or with multiple clients, for me to write it myself, so that I know that I'm maintaining it, and when a client comes back and says, hey, I need to do this, I know where to go to edit it, and I'm not dependent on somebody else for fixing bugs or problems. And in the case of S3, their libraries and documentation are terrible, as you know. And so I wrote this, which is a very, very simple way to get the S3 stuff, and it's very clear how to put in your access key ID and your secret access key, and how to sign URLs so that you can use them in other applications without having to go through the other process that you would go through S3, and it can do streaming and yada yada yada, and there's, you know, here's all 5 examples of the things that you're likely to want to do. So
You could do streaming.
Yeah, that's part of the rest.
Needed
Yeah.
that.
yeah, so
Yeah.
anyway, if you want it, there's that. You know, you're going to see that it has all of maybe 5 stars, maybe. Oh, it's got 0 stars. So let me go on GitHub though, and because this is a mirror. Yeah, I'll give it the 1st star. I won't, because it'll have me sign. But this is okay.
And that's why it's got no stars.
Because you gotta sign in.
Yeah.
No, I write tons of stuff that gets 0 stars because I'm not a people person and I don't know how to advertise my stuff and whatnot. But what I found is usually what's most popular is crap. I found some authentication libraries that were horrendous inside, that made my jaw drop. And that was one of the pivotal moments for me when I became much more okay with, yeah, I'm just going to write it myself, because it takes me less time to write it myself when I understand the protocol than it does to debug somebody else's crap and go through their PR cycle. And I feel like, I know I write a lot of crap code, but there are some things that I write that are super high quality, and this is one of them. So.
So it's one of those truisms, you know, you should never write your own security code, but occasionally, if you look at a third-party piece of security code, you think, I know not to do this, so I probably should.
Well, most things are written by people who don't know what they're doing, because the reason it became popular in the first place was because someone else hadn't done it yet.
Yeah.
Go is an exception to that, because Go, almost all of the standard library and the extended standard library are written by seasoned engineers with 20 years of operating system and programming experience. And so Go is a real, it's really different. And Rust is also different, except it's a bunch of opinionated people who can't agree, except they can agree that they'll all write different things. So that's, but it's true. This is not, I'm not making a joke here. Rust has 10 different buffer implementations because they can't agree that one buffer implementation is good enough for all use cases, and they can't agree that it's acceptable to have something be slightly not perfect for this use case. And so there's 10 different buffer implementations, and because what you want to use as a developer is 10 layers up from that at some library that handles audio files or video files or a database connection, you end up with 100 different permutations of 10 different versions of 10 different buffer libraries. So Go is better in that regard. Go has better naive implementations, and that's an empirical fact. If you look at naive code in Rust and Go, naive code will perform better in Go.
If I
Because
may
of that
say,
reason.
so this is not really related, but if I may say, if you guys ever learn a functional language, I would just suggest you do it if you haven't learned one. It makes you think about programming in a different like perspective, and I don't know. I think it's very valuable. A couple years ago, I learned Erlang, Scheme, and Lisp, and I don't know. It was a life-changing experience. You might not use it, but I don't know. I think probably not teaching like in a boot camp, because I don't know how much people use that, but
Well, where it's used, it's important. But try Haskell.org and try Erlang.org. Great resources for learning some
yeah. So
functions.
Erlang's like thing is like massive concurrency, and it's really good at doing that. And if you're starting out learning that, it's hard to apply that because you need to be working for like Bethesda and working on matchmaking servers or something, something massive like that revolves around massive connectivity. So, I mean, you can learn the language, but actually using it where it's always used is very hard.
And this is something, we were talking about how many languages, how many whatever should you learn. I completely agree that you should shallow learn 3 or 4 different languages. I think as a career, you should probably focus in on 3 languages that you use, maybe 2, maybe just 2 that you use. But I think it's nice to survey languages so that you get perspective of how patterns work differently. Because if you look at Go, you look at JavaScript, and you look at C#, there is no way that you should come to the conclusion, if you looked at all 3, that the correct way to do types in JavaScript is the C# way. You should probably walk away. I don't know how you could not walk away with saying the way to do types in JavaScript would be the Go way. Go and JavaScript are so close together in so many ways. JavaScript and C# are worlds apart. But learning different perspectives, you learn how to apply patterns in other languages. If all you know is C#, then when you think about JavaScript, you're going to try to abuse prototypes. If you know C# and C, and you look at how C code is done and how extensible C code is done, you can apply that to JavaScript. That's part of my learning path. Was I was learning C and JavaScript at the same time, and I started writing JavaScript in a kind of C style, but a little bit better because JavaScript's a little more expressive. I learned C++, I didn't like it. I started learning Go and Rust at the same time, and I took some of the Rust principles and I use it in my Go code, and I feel like it makes my Go code better. And when I look at Go and JavaScript, I think, man, this is almost a match made in heaven. I don't know how people miss that these two are like each other. But
I do think from like a purely aesthetic level of looking at code, Go from like a JavaScript, primarily JavaScript developer's view, like my view, Go looks the most natural to get into. Now if I'm gonna pick between like TypeScript and C# versus Go, it's Go. Like, yeah, so.
well, it is.
Yeah.
It's about
Less
time to wrap
context
up
switching in your head.
because we got people that gotta leave. I've got to leave. It's already 9:40. Time is
Yeah,
flying.
you too, man.
We'll see you next week. Wait.
Yeah, are
So
we
what-
meeting in December?
In December, we'll meet, and I'll actually do the classless JavaScript presentation. One more thing before y'all go, and I bring this up a lot. creativecraftsmanship.com, it redirects to this Git issue at some point. I want to make it into its own website. But if you want to learn software engineering, I recommend you learn it from people like Douglas Crockford, Rob Pike, Dave Cheney, Matt Ryer. These are people who really know their stuff. creativecraftsmanship.com. I've got links. This is a Kent C. Dodds article. These are the things that I think every software engineer ought to be familiar with. And you can always make a suggestion to me if you find a really good resource of things that ought to be here. Let me
Uncle
know.
Bob on there?
Huh?
Uncle Bob?
I actually don't have Uncle Bob on here. I have to look. I actually have not come across his stuff organically.
Yeah.
People talk about him all the time, and I like a lot of his tweets,
Yeah.
but I haven't come across.
Clean code is, that should be a class, like,
Well, he has a class for clean code.
well, no, I mean like at a school, like.
Oh, okay.
CJ.
All right, y'all have a good one. To everybody
Nice
on
to
the
meet you.
YouTubes and the Twitches, everybody say goodbye. Bye, everybody on YouTube and Twitches.
Till 10.
If you liked it, give a like. If you didn't like it, give it a big fat thumbs down because every thumb helps. But if you like the things you like, you get more of what you like. And subscribe, click all the things, check the doobly-doo. There might be some affiliate links for some book or something in the description. I can't remember what I put in there. Probably for DigitalOcean and Name.com. There's probably an affiliate code that gives you a discount on Name.com. On DigitalOcean, not on Name.com. But I might have it. Anyway, all that, and we'll catch everybody next month for the Utah JSs. Adios. Oh, and I have not been paying attention to the chat. I'm so sorry. That was a great joke. Or I guess a great response.